Okay, our next lesson is on the normal curve, and the normal curve is a graph and a pattern that follows a lot of situations in real life. So you'll get questions that say, if the data is normally distributed, what is the mean, what is the standard deviation, where is it on the graph, and so on. So what happens is it's going to look like this picture that's on here. So anything that's normally distributed, the mean is always right in the middle. So you can see the mean right down the center. And then each standard deviation line is the distance of the standard deviation going across. So you can see here, +1 standard deviation to the right, +2, +3, and then -1, -2, -3 to the left. So it works just like a number line, where the mean is like our 0 standard deviations in the middle, and then we go +1, 2, 3 one way and -1, 2, 3 the other way. So let's do an example. So if we had, let's suppose our average was, let's talk about average height. So let's suppose the average height of a person is 160 centimeters, and let's suppose the standard deviation is 10. So what that means is, in our graph, half of our population will be right at the middle, right at the 160 centimeter range, and then 1 standard deviation over would be 170, 2 standard deviations would be 180, and then 3 would be 190, and it would be the same thing going the other way. We'd subtract 10 to get 150, subtract 10 again, and subtract 10 again. So if the object's normally distributed, then what happens, that means that the majority of our data is within 1 standard deviation. So you can see on the chart, if we go anywhere between -1 to 1 standard deviation, that means 68% of our data, approximately, will be between 150 to 170 centimeters tall. If we go 2 standard deviation lines, so that's the red zone, so you can see it'll be all of the yellow plus all of the red. So that means 95% of our data approximately will now be between 140 and 180. So that takes care of just about all our entire population. Just 5% is left over. So you can see if we go to 3 standard deviations, it's almost the full 100%. There's only a little bit left. So 99.7% is our total graph, 130 to 190. Does that mean there's going to be people beyond that? Yep. We still have 0.3%, so that means there's going to be 0.15% beyond 3 standard deviations either way. So we get 0.15 on either side. So that means if you were 200 centimeters tall, you're past the 3 standard deviation lines. If you were 125, you're below the -3 standard deviation lines. Okay, so you have to know these percentages. You don't have to memorize them. You can always look back at this chart, but it sort of helps you understand what's going on. So if I gave you let's suppose if I tell you a specific data is right at the mean, and the question was what percentage of data is above the mean, what we would do is we would just look on our graph. Our mean is right in the middle. So that means everything above the mean would be 50% of our data. So that means anything below the mean is also going to be 50%. So if you add up all of the areas, you would get 50-50 on either side. So let's try one asking what is the percent above -1 standard deviations. So in this case, we're going from the -1 line and we want everything above. So if we could add up each of the ranges, or we already know that the top half, right, from the mean up is 50%, then all we got to do is add on the yellow box of 34. So we would know there's 84% above -1. What percent is between -2 and +1 standard deviations? So you can see on our graph, -2, we're going from there to there. So we'd have 13.5 plus 34 plus 34, which would be 81.5%. And we can also do ones where it asks questions something like, what percent of the data on the graph is below -2 standard deviations? So below -2 would be everything from this line down. So you can see we have 95% in between, plus that 2.35, so that gives us 97.35. So we can just do the opposite. We can go 100 minus 97.35, and that would give us 2.65. Okay, so as long as our data is right on the standard deviation lines, we can use this graph and this chart to help us figure out any kind of percentage. And that's it.